The European Southern Observatory recently began work with their gravity interferometer, the latest component in their very large telescope. Using this instrument, which combines near-infrared imaging, adaptive optics, and vastly improved resolution and accuracy, they have managed to capture images of the stars orbiting Sagittarius A. And what they have observed was quite fascinating. One of the primary purposes of gravity is to study the gravitational field around Sagittarius A, in order to make precise measurements of the stars that orbit it. In doing so, the gravity team will be able to test Einstein's theory of general relativity like never before. The gravity team used its powerful interferometric imaging capabilities to study S2, a faint star which orbits Sagittarius A, with a period of only 16 years. This test demonstrated the effectiveness of the gravity instrument, which is 15 times more sensitive than the individual 8.2-meter unit telescopes the very large telescope currently relies on. This was a historic accomplishment, as a clear view of the center of our galaxy is something that has eluded astronomers in the past. Gravity's lead scientist, Frank Eisenherr, from the Max Planck Institute for Extraterrestrial Physics, said, "First, the Galactic Center is hidden behind a huge amount of interstellar dust, and it is practically invisible at optical wavelengths. The stars are only observable in the infrared, so we first had to develop the necessary technology and instruments for that. Second, there are so many stars concentrated in the Galactic Center, that a normal telescope is not sharp enough to resolve them. It was only in the late 1990s and at the beginning of this century, when we learned to sharpen the images with the help of speckle interferometry and adaptive optics, to see the stars and observe their dance around the central black hole. But more than that, the observation of S2 was very well timed. In 2018, the star was at the closest point in its orbit to the Sagittarius A, just 17 light hours from it. It is at this point that S2 will be moving much faster than at any other point in its orbit. When it makes its closest approach, S2 will accelerate to speeds of almost 30 million kilometers per hour, which is 2.5% the speed of light. As recent simulations of the expansion of galaxies in the universe have shown, Einstein's theories are still holding up after many decades. However, these tests will offer hard evidence, obtained through direct observation. A star traveling at a portion of the speed of light, around a supermassive black hole, at the center of our galaxy, will certainly prove to be a fitting test. While those of us here at Earth will not be able to stargaze on this occasion and see S2 whipping past Sagittarius A, we will still be informed of all the results. And then, we just might see if Einstein really was correct when he proposed what is still the predominant theory of gravitation in physics, over a century later. So, that's all for this video.
Thanks for watching. See you next time.